Hello. In this next video sequence, I'm going to look a little bit more at some of the output of a linear model and try to explain the relevant values therein. Maybe you all know that already, so then it's just that I get used with my new gadget. I have now here kind of like a pad, and I'd like to get used to that to start drawing really with this pad. Let's see. Okay. On the screen you do see the output of the regression model that we've seen before. And what I would like to discuss now is a little bit what are those values here. The residual, including the residuals. Voila. From here, coefficients, and down here. To do so, we're going to go now over to my pad and we see what we can do here. So let's first start with writing down our model. We have y I is equal to, say, some intercept beta naught plus slope beta 1 covariance xi plus the error term epsilon I. This is our statistical model, and we use that to try to find the best fitting line when we have a bunch of data points. Scatter plot, like here. Something like that. When we fit a linear model in R, then the result will be, let's see if I can put in here a line. Lines maybe? R would put something like that. Well then, we would have estimates of beta naught. Let's denote that as beta naught hat, which is essentially here estimate of this intercept here. That's this. Then the second estimate, beta 1 hat, would be here an estimate of the slope. Now, how do we get those estimates? Well, essentially those estimates are functions of yi. Yi in turn depends on epsilon I. Epsilon I, usually IID, independent and identically distributed according to the Gaussian distribution with mean 0 and some standard deviation sigma. Well, because yi depends on epsilon I, yi is random, hence beta hat naught and beta hat 1 as well. So that means that this value here is a random variable as well. Has in some sense a density which is about Gaussian. About. Of course, the center here, this is beta naught hat. And this is the uncertainty, the estimate. And of course, I would like to have this as small as possible. And if we look back at our table, in R we had such a table, 2 by 2. At the beginning we had the estimates. Here we had the standard errors thereof. Here we had the t-value. And here we had a p-value. So what do those mean? Well, now we could test whether beta hat naught is 0 or not. whether this is a small value, whether it is small enough that we cannot really distinguish it, statistically distinguish it from 0. That test is then based also on a t-test, and here would be the t-value. Let's see. Quickly move this up. Oops, I want to do this. Yes, voila. Here, let's open a footnote. Here, if we have a Gaussian, 0 sigma square, okay, here, this would be probably like that. For a t density, we would also be centered at 0, but we would have slightly heavier tails, and thus the quantiles are slightly larger. But anything larger than 2 or 3 is already very, very large for such a t distribution. Okay. So that's why when you do see very large t values, you have here accordingly a very, very small p-value. Okay, that is the center table. Now let's see, maybe I can even zoom in here a little bit. Zoom, yes. Zoom, okay. Here, I'm gonna take now this color here. Here, of course, I have the residuals. Huh? I need to increase. Okay, let's pick a different color. Let's pick black. It was a bad choice. Huh? Yeah. So here are the residuals, and those, of course, are values. Okay, I have for n observation, I have n of those values. Let's denote them maybe with E1 up to En, and I can sort those. As soon as I sort, I put the parentheses here for the order statistics. And of relevance is probably this first, the smallest one, the largest one, and how they are distributed. I would like to have something which is very symmetric. Not too small values, not too large values, and all centered about 0. In one of the problems following up, I will ask you what is actually the average or the sum of the epsilon i's, of these residuals here. We see that in a second. Okay, that are the residuals, and of course this standard deviation here is linked to this sigma here. So if I would like to have an estimate of sigma hat squared, well, I would have to look at the standard deviation of these epsilon ei's. Let's zoom out a little bit further. Okay, that's the board here. Let's see, what else would I like to show you. Let me go to the previous, to our output, to see what else to have here. Okay. Yeah. So we've discussed here these values here. First quartile, third quartile gives us a little bit more information about the distribution of the residuals. We've discussed this table here. Residual standard error here is also has also been discussed, linked here to the standard error of the residuals. Okay. We'll see probably a little bit more then about the p-value here. This is the formal F statistic that's probably being discussed in the ANOVA chapter. Notice that I prefer always to look at the adjusted R squared, But that's just one measure. There are many other measures on how to assess the quality of the regression model here. And we would have here quite a small value. Nevertheless, that's about where we get. And you may have heard here, there is my son next to me who needs a little bit of attention. So let's close here this session.